In this video, we're going to use something called a switch statement, which is a bit like an if statement, but different, to work with our error checking code. And we can now finally, if the user puts in the wrong length word, we're going to keep asking them for the right length word until they finally put the right length in. Then we increment the turn number or end the game. Okay, cool. So focusing our attention on the play game method, this is where we're going to write the code for now. Firstly, it's too much of it. I want to reduce it, so we don't need to have the comment print number of bulls and cows. It's very obvious from what it says. We also, this lot here is a lot of text for just outputting two new lines, isn't it? So let's do it a different way. Let's just go \n, and then that reduces the code. Less code is generally better, less to reason about. Great, so now we go get a guess, we check the guess validity, and then we're not really doing anything with the result of that check on the guess validity. So let's use a switch statement. It's going to go in here. This is the anatomy of it. It goes like this. Switch on some expression. That's what we're going to switch based on. And then you put some curlies and you go, in the case of some constant, like I've received my error code wrong word length, then write some statements like talk to the user and break, come out of the switch statement. In another case, maybe it's not an isogram, say something to the user and break out of the switch statement. And then you always have a default that says, well, if none of the cases above occur, what do we need to do? And then you end your curlies. Okay, so let's just make a really simple switch statement here. Let's say switch based on status, and then let's put our curlies in. Cool. All right, so now what are we going to do? You go case, and then we're going to say, for example, that if the enumerator coming back out of status, so this is what status equals. If eGuess status is wrong length, colon, it's just the syntax. Check over on the slide, it says colon on the end of the constant. Then what do we do? Well, we say something. So we're going to go cout, and then we're going to go, well, let's tell them exactly what we want. Please enter A, and then we may as well go find the length of the word, which is bcgame.get hidden word length. And then we may as well say space, letter, word, and then a bit of a full stop and a \n and end the line with a semicolon. So that's it. We've switched on status, or we need standard in front of the cout, of course. And if the status is wrong word length, then we're going to output something. And then at this point, remember that we must have a break statement so we come out of the case the switch. You'll see why this is important when we have more cases. It's to make sure that all the code under all the cases doesn't run. Let's see if this works. What I'm hoping is that when we put in a wrong length, that this case will trigger and we'll get some feedback just before the game crashes. KSA. There you go. We get the bug, but we also see please enter a 6-letter word just beforehand. Great. So the user has had a little bit of feedback. So that's good news. Now, we're not going to flesh out the rest of this case statement here because we're in the wrong place, aren't we? This whole lot of code here is all about getting valid guesses, right? It's about going and getting a guess, checking its status, switching and giving feedback to the user. And we ought to tenaciously go around a loop doing this until the user gives us a valid guess. Then we come back and start submitting the guess to the engine down here. So all of this lot should be to do with getting a valid guess. So let's go ahead and do this refactor. Remember when we named get guess, we've got a to-do here saying, well, it's actually, we're talking about getting a valid guess. So let's rename get guess to get valid guess now. Okay, and then we don't need the comment anymore. Its job is to continually loop in. We can comment more at a higher level, loop continually until the user gives a valid guess. That's this thing's job. Now, we won't put the loop in just yet, but we will move some of this code down so that it's clearer. So we're going to go and get a valid guess. All of this switchy stuff can come down here now. So you go and get the guess, and then we check the guess validity and check that one condition. Now, what's better about this is that our play game method is now shorter again. We get a valid guess, looping until we do, and if you hover over it because we put that comment in, it now comes through here. Loop continually until the user gets a valid guess. Okay, then submit the valid guess, then print some feedback. And then we look in get valid guess, and we ask them for a guess. We could actually move this comment up, couldn't we, above here, and group all this together because it's all to do with just asking them for their guess. Then we check the guess validity. So what we're going to do is make the default case that we return the guess. So default, like that, and then we're going to put the return guess into the default. So if none of the errors above happen, then we return the guess. Again, let's test the code. If we go, say, planes, it's fine. If we go PLA, we get the error. So focusing on this repeating unit, I want you to write the rest of the case statements, which will be very much like this in this gap here. So the challenge is write the rest of the errors, write a message to the user for each error, tell them how to get it right next time, remember your break statements, and test the console output for the wrong word length for yourself, as I just did for myself. Okay, pause the video, go ahead and write the error messages, and I'll see you in a moment. Okay, welcome back. So let's think about what these other cases could be. Well, we can pretty much just go through the enumerators. Another good thing about enumerators, if we just go colon, colon, we've got not isogram. So let's just deal with that one. The order doesn't really matter. Standard cout, please enter an isogram, or please enter a word without repeating letters. Full stop, \n. Okay, so then it will go ahead and ask them for their guess again after that, but we'll sort the loop out in a minute. Let's just deal with all the error cases. Break, remember your break. Cool, okay, so we have another case. What's the other case? Well, great thing about these enumerators is we can just have a look inside it and see, well, what have we not dealt with? We've not dealt with all lowercase. Cool, so let's just give them a message. Again, make it a message that they can action, they can deal with. Please enter all lowercase letters. Full stop, \n. So they're helpful, right? These are helpful error messages, hopefully. Now, we can't preview any of these yet because none of these statuses are going to be triggering. But what I do want to do before I leave this video is wrap all of this in a loop. What I want to do is go round and round and round until the user eventually gives us a correct guess. So the way to do that is literally to wrap the whole lot in a do-while loop. So we go do and then open chevrons. Okay, now I'm going to delete the closed chevron in this case, highlight everything, and then down to here apart from the, we don't want the last closing brackets because that closes the whole method definition, the whole function definition. Tab in to bring it all in one, and then close your brackets, and then we can say while. Now, what is the while condition here? So we're going to do this all the time that status, now it's not helping us. Status is not there. Why is status not here? The reason status is an undeclared identifier at this point, and that's what it'll say. It says, if we try and compile, identifier status is undefined, is because we are now outside. By being here at this curly brace, we're outside of the do loop, and therefore this status here is what we call out of scope. It's not available, right? It's just not available to this while statement because it's outside of this loop. So what we need to do is declare this thing first. So instead of saying eGuessStatus at the top here, I'm just going to take away the word eGuessStatus. Before we enter the loop, I'm going to say eGuessStatus. Now I want to give it a default value. So we're going to go eGuessStatus, : Now what would be a good one to give it? I think we ought to have a invalid status, right? Because it's invalid until we've actually set a value. So let's go and do that. Let's go into the header file and let's make our first value invalid. It's actually quite a good practice for a variety of reasons I won't bore you with now. But if we put invalid status as the first value in here, it doesn't change anything else that we've done, by the way. And then we come down here, we go : invalid status. So we're initializing it to an invalid status. That by declaring it here, we now can access status inside, and that means that the while loop should be to access status. Now, it needs a Boolean type because we haven't finished. We need to compare that to eGuessStatus member OK. And is it equals or not equals? So we keep looping, let's put it in English, keep looping until we get valid input or no errors. Slightly more accurate. Keep looping till we get no errors. You see what's going on? If we zoom out, let me actually literally turn the font size down a little bit. This is the whole of get valid guess. We get a guess from the player, we ask them for their try, we check the status and give some feedback, and we keep going until we get no errors, okay? So let's see if we can make this work. Now we're getting a warning, not all control paths return a value. That's because the compiler doesn't like the fact that we may never get out of this loop. Well, I think that's okay. I'm going to live with that now. We wouldn't generally ignore warnings, but we're doing this with volition. We do want to keep looping until the user gives us a valid value. So if I just put a few letters in, please enter a 6-letter word. Okay, well, there's 6 letters. Great, I'll count them for you. And then that's the only error it's going to detect. But you get the idea. And look, the try number is not incrementing until I put in a 6-letter word. And then our try number goes up and it counts. The only thing I want to do is put an extra line in after the instruction. So where it says, please enter a blah letter word, I just want to make sure we've got 2 \n's on the end. Now, we could do that on all of these, but that's a bit weird. And also, I forgot my break statement. So let's put that break in. So rather than putting a new line on the end of all of these, what I want to do is just do it at the end of the switch statement. So I'm just going to say here, cout, end line. Of course, standard cout and standard end line. Because then it's in a single place. I'm making that format change in one place. Now, let's put in a planes. No problem. If I now put in too few letters, please enter a 6-letter word. This is looking much better. Fantastic. Great job. Take a good look at that. Make sure you understand how that method works. And we will work on making a little bit more compact as we refactor moving forward. Okay, so this is what I would suggest is on the limit of how long a method wants to be, because it becomes quite hard to reason about. Great. See you soon.